Guidance source matters. How guidance from AI expert or a group of analysts impacts visual data preparation and analysis. My name is Arpit Narichania and I am an assistant professor at HKUST, and this work was done in collaboration with Alex Endert from Georgia Tech and Atanu Sinha from Adobe Research. Today, there are numerous generative AI offerings such as copilots and AI assistants that strive to provide better guidance, particularly during data analysis. However, there is a complex interplay between algorithmic and human judgments in how people trust and utilize guidance. For instance, people trust emails less if they know AI helped write them, whereas people accept AI recommendations more than human experts in ethical decision making. In visualization literature, there is a typology that characterizes guidance-related tasks into 4 dimensions, basically what guidance to provide, why, how, and when. However, the perceived efficacy of the source from which guidance is offered and its utilization during analysis has not been examined yet. In this work, we study a new from whom dimension, studying how people utilize guidance if it comes from an AI model or fellow humans. In particular, we ask, how do users perceive and utilize guidance from different sources with particular interest in an AI model, a human expert, and a group of human analysts, since these are natural candidates from whom guidance can be provisioned. To investigate this research question, we designed a 5-condition between subjects study. In addition to AI expert and group, we consider a 4th guidance source, unattributed guidance, wherein guidance is provided without attribution to any source. This condition serves as a baseline, enabling us to isolate and compare the effects of the 3 source-specific guidance sources. And lastly, we also consider a 5th control condition, which serves as a baseline to evaluate the influence of any kind of guidance. We recruited 87 participants from a pool of graduate students within a public university in the US and conducted a remote asynchronous study as follows. First up, we asked participants their current opinion if guidance can be beneficial during analysis on a 7-point Likert scale ranging from disagree to agree. Next, in what we call the pre-phase, we provided participants with some background about AI usage and our study task, namely the concepts of subset selection and visualization dashboard creation. Next, we primed participants as per their assigned study condition that they will receive guidance in the form of attribute suggestions from an AI model trained on large information for data analysis tasks, or a highly regarded industry expert, or a group of data analysts in the organization. Next, we train participants via a video demonstration of the study interface and a practice task. Next, we asked participants about their opinions on specifically receiving guidance from the source assigned to them, whether guidance can be reliable, can increase confidence, and can add value. Next, we provided participants with the actual task instructions to analyze the given dataset of online customer behavior on an e-commerce website, select 5 to 15 relevant attributes indicating meaningful drivers of dollar sales revenue, and create and save at least 3 visualizations for examination by your boss. For instance, consider this dataset snippet. A participant may select timestamp, name, price, and city as relevant attributes and make visualizations using them. During the task, participants can request simulated guidance from their assigned source, for example, an AI model. Now, one guidance request is equal to 1 attribute suggestion, for example, postal code. Participants can request guidance for a maximum of 10 times, of which 7 suggestions are relevant, determined with the help of an industry expert. Note that this was by design to simulate a real-world-like scenario. Also note that participants did not know that we were controlling the guidance quality in this way. Let me show you our study user interface. So in this tool, users can upload a dataset and inspect an underlying attribute's name, definition, summary data distribution, and also individual records. After inspection, they can select it into their subset by checking the corresponding checkbox. And once selected, users can create different data visualizations using the selected attributes. For example, a bar chart showing average sales purchase price across different marketing tracking codes. And finally, users can save the different visualizations to later share with their boss. Now, to request guidance, users can click the Ask for Guidance button in the Guidance panel. And depending on the assigned study condition, this guidance can come from an unattributed source, as in this case, or it can come from a human expert, group of data analysts, or an AI model. So after completing this task, we asked participants their views about guidance, if it was indeed reliable, increased confidence, and added value on the same Likert scale. In addition, we also asked participants how much they relied on and regretted using the offered guidance. We concluded the study with a demographics questionnaire. Now, to help us answer our research question, whether the guidance source matters, we first statistically test 5 pre-registered hypotheses. 3 hypotheses compare the source-agnostic unattributed guidance with control, and the remaining 2 hypotheses are more source-specific, comparing guidance from an AI with an expert and a group. First, H1. We hypothesized that participants who receive guidance will be less uncertain about their attribute selections. We define uncertainty as the variance in number of interactions with the attributes. For example, high variance suggests participant is repeatedly interacting with an attribute, unable to decide whether to select it or not. We find that participants who received guidance are in fact less uncertain about attribute selections, but this finding is not statistically significant as per a one-sided Mann-Whitney U-test. Next, H2, wherein we hypothesized that participants who receive guidance will select more attributes. We find that participants who received unattributed guidance did in fact select more attributes than control, and this finding is also statistically significant. Next, in the interest of time, I will skip H3 and H4 and directly jump to H5, wherein we hypothesize that participants will verify the guidance more when it comes from an AI than an expert than a group. We define verification as the number of interactions with guided attributes before and after guidance. We find that participants receiving AI guidance do in fact verify the guidance more than an expert than a group. And the pairwise comparison between AI and group is statistically significant as per a pairwise one-sided Mann-Whitney U-test with Bonferroni correction. This leads me to our first key takeaway, that guidance source matters in people's utilization of guidance during analysis. Next, we performed behavioral analysis based on participants' interactions in the user interface. For example, exploitation of guidance availability, measured as the total number of guidance requests out of 10. Notice AI among attributed sources. We wonder if there is a general belief around AI guidance to be more salient. Next, we analyze participants' eagerness to access guidance, both in terms of the number of interactions and also the time spent until the first guidance which was requested. Notice the high eagerness to access guidance under group. We wonder if this is because the stored knowledge from group is psychologically more accessible than an AI or an expert who may be perceived at a higher level. These behavioral analyses lead me to our second key takeaway, that participants utilize guidance differently at various stages of analysis. And lastly, we also performed analysis on the self-reported participant responses in our questionnaires. For instance, we plotted participants' perception of guidance that it can add value before the task on the x-axis against their opinion after utilizing it during the task on the y-axis. Notably, participants receiving AI guidance reported it added the most value. Next, we also plotted participants' reliance on guidance on the x-axis and their regret using it on the y-axis during the task. Interestingly, participants receiving AI guidance reported the highest regret as well. This leads me to our third and final key takeaway, that participants receiving AI guidance reported both higher post-task benefit as well as regret, calling for a more nuanced interpretation of AI's role. All three takeaways strongly indicate the need to further understand how different guidance sources impact user behavior for designing effective guidance systems. Note that our study had a few limitations. First, our task was somewhat subjective, as the relevance of attributes in data analysis can vary based on user interpretation, making it difficult to establish a clear ground truth. Second, we did not provide any explanations or justifications for the provided guidance. For example, the AI's reasoning, which could impact users' trust and understanding. However, despite these limitations, our findings offer valuable insights. We also identified some opportunities for future work. First, studying the underlying factors contributing to participants' regret during guidance utilization, and also devising means to mitigate them. And second, studying how user expertise influences guidance usage. For instance, do experts request guidance less frequently, or do they rely on it at specific stages of analysis? And with that, I conclude my talk. Thank you.